Good day, guys. Today we'll be doing equations of a tangent to a curve. So let's say you have a curve, is this curve, right? You want to know the gradient of this curve at that point. What you can do, you can draw a tangent line that touches the curve at that point, and the gradient of this tangent line at that point is equals to the gradient of the curve. So how can you find the gradient of the curve? First things first, you have to find the derivative of the curve. After you found the derivative of this curve, you have to substitute the x-coordinate of the given point into the derivative to get the gradient of the tangent. So they're going to give you a point. They'll probably tell you find the equation of the tangent at point x is equals to 2. So after you've done your first derivative, in that expression you have, after applying the rules of differentiation, you have to substitute your x with 2. The answer you get there, it will be the gradient of your tangent. And then you'll use that gradient and that given point to calculate the equation of the tangent, which obviously has to be a straight line. So you'll use the gradient you calculated after finding the derivative and the point given to you to find your line of to find your equation of your tangent, which will be a straight line. So you have to find the equation of this form. So without further ado, also remember that if this is the tangent and this is the normal, the gradient of the tangent times the gradient of the normal will give you -1. Why? Because they are perpendicular to each other. So also keep that in mind. So without further ado, let's do some examples. Here's the first question. The question says g of x is equals to open bracket x plus 2 close open 2x plus 1 all squared. So I have to find the equation of the tangent at x is equals to 1. So first things first, I have to expand this. So this thing can be written as g of x is equals to 4x to the 3 plus 4x squared plus 8x squared plus 8x plus 2. That's what you'll get after expanding that. And then your derivative will be 12x squared plus 8x plus 1 plus 16x plus 8. And then after that, I have to substitute my given x point on the derivative. So if I substitute x is equals to -1 there, it will be like this: 8 minus 1 plus 1 plus 16 into -1 plus the 8. You will get -3. So g of x at -1 is equals to -3. So the gradient of our tangent, it's -3. But we have not finished, because remember, we're only given one point. We're only given -1, which is was our x. So now we have to find our y. So for you to find your other coordinate, please go back to the original equation you had before, the original one, and then at the original one you substitute your -1. So you'll get -1 plus 2 square bracket into 2 into -1 plus 1 all squared. So you'll get that your y will give you 1. So your points are actually -1 and 1. And remember, when you are looking for your y coordinate, you use the original g of x. You use the original g of x, not the derivative. The derivative will only give us the gradient. For points, please go back to the original function. So this is our point we're given. So now let's find the equation of the tangent line. So y is equals to mx plus c. My y, it's 1. My m is -3. My x is -1 plus c. So my c will be -2. Therefore, the final answer is y is equals to minus 3 x minus 2. That's your equation of the tangent to this function at x is equals to minus 1. This is the formula of the equation. So let's do another example. Here's another question. The question says, determine the equation of the normal line, not the tangent, the normal line to the function xy is equals to minus 4 at this point. So first things first, I'll say write this function in the standard form, you know. So it's going to be y is equals to minus 4 over x, right? And then remember that this thing is the same as minus 4 times x to the minus 1. So then your first derivative is going to be minus 1 times minus 4 is 4 times, and then here will be x minus 1 x to the minus 2. So your derivative is going to be 4 over x squared. So then it's time for you to get your gradient. So your gradient is going to be your derivative at what? At x is equals to minus 1. So here you'll have 4 over minus 1 all squared, which will give you 4. But remember, this 4 is the gradient of the tangent. We don't want the gradient of the tangent. We want the gradient of the normal. So what are we supposed to do? We're supposed to use this formula, which means that the gradient of the tangent multiplied by the gradient of the normal we're looking for must give us minus 1. So the gradient of the normal will be minus 1 over 4. So since we found the gradient, now we can write the equation of the normal line to this function. So y is equals to mx plus c. Your y is given to you, they said is 4. The gradient is this one we just calculated, is minus a quarter. Then your x is minus 1 plus your c. So your c will be 15 over 4. Therefore, your equation of the normal line to that function will be y is equals to minus 1 over 4 x plus 15 over 4. You've answered the question. Let's do one final last question. The last question says that determine the point where the gradient of the tangent to the curve this f of x is equals to 1 minus 3 squared is equals to 5. So now we are not looking for the gradient is given to us, we are looking for the point at which the tangent line touches this curve. So obviously the first things first we have to do, we have to find the derivative of our given function. So derivative of our given function will give us, derivative of a constant is 0, and then here will be 2 times minus 3, which will give us minus 6x. That's our derivative. So since we've been told that this is 5, so we can substitute 5 there, 2 minus and then 6x. So it means that our x will be negative 5 over 6. That's our x coordinate. So for us to find our y coordinate, we have to go back to the original function, which is this one, and then we have to substitute our x there. And then you'll get that your y is minus 13 all over 12. Therefore, the point at which the gradient is equals to 5 is actually minus 5 over 6 and minus 13 over 12. So this is your final answer. So I'll leave it here for today, guys. So if you appreciate the content, please remember to comment, like, subscribe and share. Thank you.